Good evening, everyone, and thank you for joining us for the next Teacher to Teacher webinar series put on by Mountain BOCES. Tonight I have the pleasure of introducing to you Beth Skelton. Beth has been working in the field of education for more than 25 years. She is passionate about language learning and especially about making academic content accessible to English language learners. She has taught English language learners at many age levels and in a variety of school settings since receiving her master's degree in multicultural teacher education from the University of New Mexico. From 2010 to 2013, she served as the program coordinator for ESL at the Bavarian International School in Munich, Germany. She currently supports schools in their quest to provide equitable education for ELLs and provides professional development for educators across the United States and internationally. Beth, please take it away.
Well, thank you for that introduction, Will. Good evening to everyone here tonight and welcome to this webinar focused on the language of math. Although I'm not a math content specialist, I have worked with English language learners from elementary to middle to high school, and I've noticed that many really struggle with the language of math. And many educators actually believe that math is a universal language, but I hope that this webinar will raise your awareness of the language of math and provide some practical strategies for supporting your students in developing this very specific academic language. So if you haven't done so already, please download the handouts that support this webinar. In the bottom left corner, you'll see the box to do that. So specifically, tonight's webinar has a few objectives. We're first going to apply 3 basic principles of English language learner instruction to math. So these are generic principles for ELL instruction, but I'd like to show how they apply to math instruction as well. I'd like to deepen your understanding of how culture can actually impact comprehension in math and raise your awareness in that way. We're going to analyze language use in a math class via the video, one of the videos. And finally, you'll get to observe as well as practice a cooperative learning strategy that can support language development and math concept development. So that's what I've got for the next hour, and hope that supports what you're already doing as well. But I know that there are a variety of people here tonight. I know some of you already, and I'd love to know what your role is in education. So before we dive into the webinar, if you would please just type your responses to this question, what is your role in education, in the chat box. And if you are a teacher, please include what you teach and where you teach. So I'll wait while those answers come in now. That's great. We've got some grade level teachers here. Kelly Wisniewski, if you're watching, I know is a math coach, so she's going to probably coach me on some of the math as well. We've got paraprofessionals as well as speech language pathologists, teachers, and special ed. And so hopefully this will meet some of you specifically around when you work with math in the grade level classroom and with the students that you work with. So let's turn now to a quick overview of those 3 principles that are actually going to outline tonight's webinar. So for those of you who have had any SIOP training, or if you've worked with the Center for Applied Linguistics, these 3 principles will be quite familiar. So above all, teachers must always strive to increase comprehensibility of their instruction. And as you plan your lessons, you'll be asking yourself how you can make the math concepts concrete and comprehensible. And I know you're already doing things like adding manipulatives or explorations, drama and drawing, realia or real objects. You're adding that whenever possible, and I'm going to show you some specific examples tonight of how that works. We have to think about new math vocabulary terms and how you can explain those and practice them in a variety of contexts. You'll be rereading any word problems for possible cultural misunderstandings, which I'll address more specifically later in the webinar. Another area that we'll focus on is how to increase interaction. This central tenet of WordX, English language learners, directs us how do students actually interact with the math materials as well as with each other during instructions. We look at our lessons and think about how am I going to structure their opportunities to explain their comprehension of the math terms in a meaningful context. Are they going to work cooperatively with each other rather than just one-on-one answering a question? At the end of the webinar, we'll actually practice one Kagan cooperative learning structure together. And then finally, throughout math lessons, we're really trying to increase higher order thinking skills. So ELLs may not yet have acquired all the English necessary to express comprehension, but they can still think critically and be challenged with work at high cognitive demand. So this principle is going to be addressed throughout the webinar. I had the great fortune of working with a beginner in English just yesterday in 4th grade, but the student was very, very strong in math. And the teacher was giving the student all kinds of possibilities to express his understanding and thinking, even though he couldn't speak English. So let's jump into that first principle of increased comprehensibility with a challenge problem for you. Increasing comprehension is really supported by the National Council of Teachers of Mathematics that argues that math must be more than the mere manipulation of numbers. This principle is also supported by the Common Core State Standards, which says that math must the students must make sense of problems. So both of these areas really support this principle of increasing comprehension. So with that in mind, here's your challenge. How would you make this problem 1 3/4 divided by 1/2 meaningful and comprehensible? Now, I know that some of you are working at the elementary levels and you may not have your students dividing fractions yet, but you can just think about how would you make that idea, that concept, comprehensible. At this point, the challenge is to take a moment to type some ideas of how you would make that concept of dividing fractions meaningful to the students. Type your ideas in the box now. Stacy, we were brainstorming together. Let's see what happens next. There's a couple more ideas coming together. Lots of people thinking pizza. Must be dinner time. And Megan with the visuals, you're exactly right. So I'm going to wait for a couple more types to come in, and then we're going to jump in and see some possibilities. Yeah, Sarah, you're going to hear that language fits into exactly used in this next lesson, because that's really what we're looking at, is how many halves fit into 1 3/4. So usually kids think about division as the answer is going to be smaller, that we're making it divided by meaning smaller, but we have to show them that it's really about how many halves are going to fit into 1 3/4. So just like with you guys, all your ideas are coming up. We had a similar idea with pizzas. So first I would just show it what it looks like. So Stacy had the same idea. Here's some pizzas. I have one whole pizza, which is 4/4, and I have 3/4 of another pizza. So how many halves fit into that? And that can be shown using the same visual You can simply show them, here's 1/2, here's 2 halves, here's a 3rd half. Oh man, and I have a half of a half left. So that just visually gives them an idea. Now, some math specialists and the Common Core state standards would argue that by the time students reach this level of division of fractions, that they would actually be at the number line stage, that they wouldn't need this kind of visual support. I would argue that some of our English language learners who are jumping in to 5th grade, 6th grade, 7th grade, later in their career may or may not have had the comprehension built first. So once the comprehension is built, the recommendation is to move to a number line so that they can really figure out the problem understanding from that level. Another way that you might explain the problem is to do a story. And I saw that in the chat box as well. So here's a story that I might give the students is, I want to make you some chocolate chip cookies. And the recipe calls for 1 3/4 cup of flour, but I only have a 1/2 cup measuring cup. I'm so frustrated. Can you tell me how many scoops of flour I should put in the recipe using my 1/2 cup measuring cup so I can bring the cookies tomorrow? And then I might send the kids back to their tables where I've previously talked to the janitor about what's about to happen. And I would have a bowl of flour and a 1/2 cup measuring cup. And then I might give them the option of saying like, oh, my colleague loaned us a 1 cup measuring cup just so they can double check their amounts. So as they're measuring and exploring, can they figure out how many 1/2 cups I would need to make 1 3/4 cup of flour to make them cookies for the following day. So we were all on the same line of somehow making this idea of division, how many 1/2 cups fit into the 1 3/4 cups so that you can get it. That's the plural of half. So writing that on the board and pointing out that half changes to halves to make the plural so they can understand what you're saying is really key for understanding this problem as we discuss it in class. Well, another idea that we can jump into to make math comprehensible are the things that you brought up in the chat box already. Of course, all kinds of visuals, drawings, manipulatives, anything that's going to use drama can really support the students with math. Demonstrations are huge, and I know you're doing that. Of course, lots and lots of repetition, not only of the vocabulary, but also of the concept in different contexts. Integrating total physical response, that's the TPR, total physical response. So having them show you an acute angle with their arms versus an obtuse angle. Whenever you can add the TPR, the physical response, that's huge. And then finally, where we're going to go next is to consider culture. What does that really mean for math? I'd like to introduce that with an example in French. Now, if you are a French speaker, you won't have a problem with understanding this following word problem. Word problems being a challenge. If you don't know French but have some Spanish background, use all of your Spanish background, your cognates, anything you can find. If you don't know Spanish or French, look for cognates. Look for words that look like English, and you'll do okay with at least figuring out what the question is. So here's the word problem. Now, French is not one of my languages, but I'll try to butcher it for you. Jean et André sont frères. Jean is l'aîné. Les deux vont dans le lycée qui les trouve à moins de 100 km à l'heure, marchant à Paris. Bien qu'il y ait une différence d'âge de 3 ans entre les deux frères, leurs niveaux scolaires ne sont séparés que par 2 années. André est en 6e. In quelle classe est Jean? Can you understand at least the question that it's asking? What are we trying to find out? Go ahead and type that in the box so everybody's online. What are we going to try to find out? Great. So Sarah has already figured out that classe in French is grade. So we're trying to figure out his grade. And some of you saw the word age, and that is going to come in handy as well. So some teachers are really helpful with the students, and they will go back into the problem and they'll say, here are the important parts of the problem. So let's try and see if that helps you. If I underline the key information, so Jean is l'année, une différence d'âge de 3 ans, maybe that helps you some. Séparé que pas 2 années, and then André is in 6e. So if that helps, if that's giving you some idea, you're focused now on the key numbers and ideas that you need to solve this problem. Some of you at this point are already able to answer the problem. If you can, because of your Spanish and or French background, go ahead and type the answer into the box. So Sarah, I'm guessing that you've got some French background. Okay, Carol. Okay, some of you are really getting close with this. So let's go ahead and give the English translation, because sometimes we partner kids up with someone that speaks their language and then they can actually translate. And let's see if this helps. So Jean and André are brothers. Jean is older. That was great. You guys got that. The two go to a school which is found less than 5 kilometers from their home. That's all garbage. We don't need that. Although there's a difference in age of 3 years between the two brothers, their grade levels are only 2 years apart. André is in 6th grade. What grade is Jean in? Now that you've got it in English, if we know that Jean is older and André is in 6th, what grade is Jean in? Go ahead and type it in the box. Okay, so now that you know that Jean is older, the answers are changing. And I'm guessing it's Jeanne Martinez, or yeah, is still going with 4th. So as a teacher, I look at these answers, either 8th grade or 4th grade, and I'm wondering, of course, do the students not know how to add or subtract? Is that the problem? Well, it looks like only Jeanne Martinez actually understands how the French system works. And here's how culture impacts math. The educational systems in the US count up, grade 6, 7, 8. But in France, the grade levels go down. 6 years to go, 5 years to go, 4 years to go, 3 years to go. And of course, when you're done, you're terminal. So now we know that Jean is actually in 4th grade. Nice job with Jeanne Martinez, the one who actually got it. Sarah and Carol originally got it, but maybe I didn't know if they understood the problem or they changed their answers when they learned what older was. So to see how culture can totally impact how our students do math. The problem with culture is that we don't necessarily know what's causing the problem. It's so easy for us. We assume a lot of background with culture. Let me give you some ideas of how, thanks Sarah, you can use it. It's on the PowerPoint. It blows me away every time. Here's some other ways that culture can impact math. Can you name the cultural referent or the antecedent? What is this number referring to? So in the box, go ahead and type, it's usually just one word. So for example, it's 5.99. If you heard that 5.99, you'd type in the box simply money. Okay? It's referring to dollars, money. Here's the next challenge, and you guys type, I'm not going to give it away. It's 2:30. Super. So everyone's like, yeah, it's time. But why do we know that 2:30 is time and 5.99 is money? Why couldn't 2:30 be money? These are cultural assumptions. Try another one. Type in the box. What is this referring to? He's hitting 375. Awesome. You guys all know baseball. How about this one? She's 5'3". Right on. It's the height. Okay, here's a challenge one. He's 3 for 125. No one's typing away on this one. Perhaps it's because this is outside of your cultural reference. This refers to cricket. Now, no one had problems typing in 375 for baseball. He's hitting 375. But he's 3 for 125 is a way of talking about cricket, a sport that's played in any former British colony or in the UK right now. That would be a cultural reference that every student in the UK would understand, that they're talking about cricket, not baseball. So do you see how these numbers that we throw out in math class, we assume that if I say it's 2:30 or it's 2:30 plus whatever amount of time, that the kids are understanding it's time. What's 15 minutes more than 2:30? We assume they get time. These are assumptions that culture impacts in the math class, and just something to think about as you look through any word problems that you're giving or how you're talking about math in class. Does it need some kind of visual or explanation of the cultural reference? So another area that impacts math a lot is vocabulary. And I hear about this a lot in classes, and I know that teachers are focusing on vocabulary challenges. I'd like to address about 6 different vocab challenges, and all of these are in the handout to support you as you go through. The first vocab challenge that I'd like to address is something called polysemous words. That's a big word to mean multiple meaning words. These are words that have a common and a mathematical meaning. They're spelled the same, they're said the same, but they have different meanings. And I listed a bunch of these on the cover of your handout and on the first slide. There's a hint. Can you type in any of those polysemous or multiple meaning words that come up in math, such as table, mean? Go ahead and type in any more that you're thinking about. Wow, you guys have a lot of great ones, including power and plot, round, takeaway, area, comparison. All of these are used in different contexts in different content areas. Negative, man, that's such a negative comment versus negative in math. To carry something, to borrow something. Um, Other examples that come up for polysemous words in math. Super. So keeping that in mind and teaching specifically when it comes up in your math class, how it is different than that same word when used in a language arts class or in a social situation. Another vocab math challenge for our English language learners are homophones. Some and some, pair and pair, sign versus sign. These really throw off our students. They are hearing the word some and not hearing SUM. So sometimes writing those words on the board as you say them can be a support for those students, pointing them out, putting those words on the word wall, and just helping the kids to recognize that those two words sound similar. A third vocabulary challenge area are minimal pairs. Now, what this means are the words that, for English speakers, native English speakers, we can hear the difference between 13 and 30, 60 and 16. But even as native English speakers at the checkout counter, you might ask, how much was that? Was that 6:30 or 6:13. So even for native speakers, these are tough words. The minimal pair means that there's a minimal difference for them. For English language learners, these are extremely difficult to hear the difference between. When you are giving oral number directions, such as, please write down the following problem, write those minimal pairs on the board so that the students have a clue about what you're saying and they get the difference between 60 and 16, 50, 15. It really, really helps for you to write those numbers as numbers rather than words for the students. A fourth vocabulary challenge is the difference between social and academic language. We're going to look at some of these terms right now and see how our social language can actually support their mathematical understanding. So as we look at, as we look at the social language term of guess, students may know that. And a Stanford study in a paper called Principles of Mathematic Instruction for English Language Learners, it argues that everyday language and mathematical language are interdependent and related. They're not mutually exclusive. So it's actually okay to connect the math terms to the word guess. So the math terms for guess, you probably would say, are estimate or conjecture, depending on the level or what you're doing. At this point, we're going to type in the box. What are the math terms that you could connect to the social language rule? Kids learn the word rule. We have rules in the classroom. This is what we're going to do. Follow the rules of the game. What are the math terms that go with that social language? Oh, there's a lot of options. You bet. You guys got a lot of them. And I had axiom, property, formula. I think algorithm could work as well. These are the rules of math, but connecting axiom or property or formula back to rule can support students' understanding. Again, they're interdependent for those students. And here's another challenge for you. What about the word same? Can you go ahead and type in the box? What would you say for the math terms for same? Right, equal. How about congruent for same in geometry, or equivalent? Nice job. You guys are catching all of these. Again, connecting back. So that Stanford University paper, Principles of Mathematics Instruction for ELLs, is found online. It's a free PDF, and it's in the references at the end of the handout if you'd like to look at that. Really encouraging us to connect the social language to the math terms. So in addition to these vocabulary challenges that we've already addressed, the polysemous words, homophones, minimal pairs, and the social versus academic language, there are some specific challenges for our Spanish speakers, the majority of our students in Colorado, at least in the Western Slope Mountain region. And I know we have diversity, but for Spanish speakers, there are false cognates. These are just a few to be aware of. Largo means long, not large. Restar means subtract, not rest. And resto is the remainder, not the rest as in relax. It's a remainder. So some of these can be like false cognates, meaning the students might see, we might try to use that, but it's in the wrong meaning. So false cognates are those words that look like English, like largo looks like large, but it really has a different meaning of long. So most cognates in Spanish are not false. They actually support student learning and comprehension. So in your handouts, I've provided a reference to a list of common academic words and their Spanish cognates, so you can support your students in making connections between Spanish and English terms. There's a reference. This list was a doctoral thesis by a student, and I gave you a link to it finding that. So if you're aware of the cognates in an upcoming lesson, you can actually point out those true cognates and help your students who have been educated in Spanish, or even if they have support in Spanish at home, that they can develop those cognates. And then finally, a challenge in math with vocabulary are these really conceptually dense words. Words like exponent or common denominator or properties. Each of these terms requires a deep understanding of a concept, not just a definition. Judy Moshkevich, who authored the Stanford paper I mentioned before, explains that math instruction should move away from these simplified views of language and interpreting language as just vocabulary or single words or a list of definitions. Math instruction should focus instead on mathematical practices. And certainly the language that holds these ideas is critical, like exponent, but just providing a definition of that individual word, like common denominator, is not going to help the students. They need to see the concept of what that means in a multiple contexts in order to get it. So just keeping in mind that definitions don't always help with these intense words. So moving on to another challenge for comprehension, which is our big theme right now for English language learner, I'll call it grammar issues in math, because grammar can really affect English language learners and their comprehension of math problems. So let's look at just a few math grammar issues you should be aware of, and then possibly even explicitly teach in your math lessons, because as we know, we're all language teachers. So many math problems from kindergarten on use the comparative form of adjectives. So we have to teach students that an adjective with an ER shows that something is more, and that preposition than shows that one thing is compared to another. You already typed in the chat box this word comparison, huge in math. So acting out comparisons in class, focusing on the language of comparisons like taller than, longer than, shorter than. Once they understand that word than, they know we're working on a comparison and can really support their comprehension as well as their language development. So another way to compare is the structure as. So this pen is as long as that pencil. An equality. So does that iPad cost as much as this computer? That structure as used a lot in math and can really throw students off. They don't know what it means. So teaching that as a language structure is super important. They don't understand how the comparative structure works, and then they can't answer the question being posed in a math problem. So prepositions are also a difficulty for English language learners. Let's look at how just one preposition can completely change the understanding of these statements. The temperature fell by 12 degrees. So we have a vision of what that is. The temperature fell from 12 degrees, totally different meaning. And finally, the temperature fell to 12 degrees. Even students who understand the word temperature, because I've given this great visual, may be completely lost when it comes to figuring out how to solve a problem because of the difference in the preposition. So even a thermometer with movable dials to figure out the problem, even working with it with manipulatives, they aren't going to understand it if they don't understand the prepositions. So if nothing else comes out of this webinar, it's that we all have to be language teachers. And if you have other examples of how prepositions or the grammar of math may have caused a difficulty in understanding in a lesson that you've recently taught or a student that you've supported, go ahead and type that in the box if you're thinking, oh, that may be why my student struggled with this problem. Is there anything coming up for you using prepositions? I see some people typing, but answers aren't coming through just yet. I'll wait another moment for those answers to come through. Oh, that's a good one. Explain that borrowing from the tens. That's a great one. Um, what does that mean to take it from something? Yeah, you guys are on the track. So just explaining it perhaps outside of a math context and then bringing that into the math and really showing the students how the preposition works. Yes, um, the Spanish speakers prepositions are probably the most difficult. A lot of prepositions like in and on, very, very difficult because in Spanish there's just N, E-N. In any language, prepositions are one of the most difficult things to learn. And in math, it actually impacts meaning. So thank you so much for sharing those as other ideas. So now that we've looked at some of the language issues that ELLs face in math, we're going to have the opportunity to analyze the language that two students use in a third grade classroom of math. Now, some of you may have seen this video. I'm going to ask you to focus in this viewing of it how Sarah and Carlos, the two students in the video, use language to express their understanding of addition problems. I'd like you to focus on the different kinds of vocabulary the students use, as well as the grammar or that sentence level that they are acquiring or working on right now. After we watch the video, I'll have you type some notes into the chat box about that vocabulary and the sentence level. In your handout on page 3, you'll find a place to make notes as you watch Sarah and Carlos express their understanding of addition problems. It's a 5-minute video, and when that is complete, go ahead and start typing your notes in the chat box about what you hear those students using as far as language and sentence structure goes. And as Will types, we're going to watch it on our own, not on the webinar. I'm going to go ahead and click on it as well, just so I know that when the video is over and I'll see you start typing in the chat box, which you can do all along if you want. All right, see you in 5 minutes. So the video has finished on my end of things. Hoping that most of you were able to get through it as well. And as you finish watching, if you would just go ahead and type in the box, what math vocabulary did you hear the students using? Great. How about the sentence structures? The decompose, I love that. How about the sentence structures? What, you don't have to type out the whole sentence, but some of the complex sentences that you heard them use. If you wrote any of that down, if you were able to catch it. Were they full sentences? Were they simple sentences? Did they have transition phrases? What were you hearing students use at the sentence level? Great. Absolutely. So you really were able to recognize their language development. This teacher was clearly focused on mathematical thinking as well as the vocabulary and sentence structures necessary for students to explain their thinking. So I, just like the rest of you, heard splitting and decomposing and broke into and carried and table and equaled and added all in the vocab level and cost. And it's sentence structures, just like you were seeing, we do mental math because, so going into a complex sentence, so you can just do it in your brain, like a therefore, that word so. Then I, and went into transitional phrases. First, I made a table. And then there was that for the first teacher as an introductory phrase from Sarah, the student Sarah. All of these show me their language development level and can give me ideas on how to support their language within the context of math and how to support those students to come to the next level of language development, even in the math class. So let's go ahead and practice what these students were doing and see how that language of math, how we use it. So we're going to try that right now. We're going to use the language of math to do some simple addition. Step 1, go ahead and type the number of years you've worked in education in the chat box, and that can be in any capacity as you've worked in education. We're going to have to see each other's numbers. Oh, these are great numbers. Awesome. So the next is we're going to add up those total numbers of years of experience in this webinar that you see. Use mental math, no calculators on this one. Awesome. Everyone's taken Sarah's answer, but that's not the whole response. You're using mental math to figure it out. And now the big question. Explain your process of adding up the numbers that you see. How did you add it up? So did somebody take 3 and 7 to make 10? How did you add it up? That's what you're explaining right now in the chat box. It's going to take a minute as you explain your process. How did you do it? Great. So I'd like you to notice, you can see each other's, you can see your explanations. So Sarah is giving me first I added, then she's using linking words, some transition phrases. Tanya is using I put together. I put the 25s together. So if I were going to work with Tanya and say, okay, she needs this math vocabulary of adding, and I'm giving you an idea of how I would work with my students. Put together, I understand on a social language, but I'd want to have the academic language. So you can see the language that we need, and then Will totally skipped the language part and just did it in mathematical formulas. So how do we express that in words? As you know from the Common Core, students are actually having to explain how they're solving problems and using language. And we can notice the language that's necessary is beyond the vocabulary level. It's really at that sentence level. What supports would have helped you with that? Would you have needed a sentence frame for explaining it? First, I added blank and blank. What if I had given you a word bank, or I gave you a model or an example? Maybe if you'd had practice time with a partner before I had you type it into the box, that would have supported you. So structured partner interaction is the next place that we're going to go. All of these are great examples of how language impacts the process when you're explaining the process of how you do a problem. So all of you are able to add it up, but how? That's what's key. And that's where we're going to move into next is explaining your math process and getting some interaction involved. Actually, I think I'm going to skip this video. You have the link. And in this video, you will see students interacting with each other to explain their thinking. But what I'd like to do, looking at the time, is actually practice one of these strategies from Kagan Cooperative Learning and give you a chance to see what it's like to participate, focus not only on the math itself, but on the process of explaining it. So we're going to skip the video discussion because of timing so that we have a chance to work through one interactive cooperative learning strategy from Spencer Kagan. So Kagan is this master of cooperative learning. He's been around since the early 80s, and several of his cooperative learning structures are focused absolutely on math. And one of those is called Sage and Scribe. We are going to practice Sage and Scribe and pretend we're sitting next to somebody in the classroom. And in Sage and Scribe, the sage explains step by step, verbally, out loud, how to solve a problem. The sage may not write. So the sage is all about the explanation part. The scribe writes what the sage says, step by step. If the scribe feels like that's not exactly how we do it, or I think you went wrong there, they can certainly ask for clarification or disagree. They don't have to just mindlessly write. But the process is that after the teacher has explained a step-by-step process, you've practiced together as a whole class, you've done a you do as a teacher, we do as a whole class, and now it's time for the students to practice independently. This structure really can support their language and concept development. Now, students may need sentence frames as additional support for this to express their thinking, or maybe to help them guide through each of the steps. We're going to be the sage. Our scribe will be pretending to sit next to us, and we're going to go ahead and do some fractions, since many students seem to struggle with anything to do with fractions. Again, remember that you would ask the students to use this interactive structure only after they have an understanding of the concept. You've already practiced it as a whole class. They have several models already. They understand the key vocabulary for explaining the concept. The native speaker or even the stronger language user would go first as the sage, but they don't stay the sage the whole time. They change roles. Maybe after 2, 3 problems, then the scribe becomes the sage and then tells the sage how to do it. They just switch roles. So let's practice. We're the language models in this situation. And we're going to type in the text box, how would you begin explaining the steps for this problem to your partner? And we may not have time to get through all the steps, but what might you say is the first thing to do, the next thing to do? If you could start with that. First, da 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 da, next, da 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 da. Go ahead and type that in the box. Super. So Sarah has typed in the explanation. And if she were telling her scribe, if you were sitting next to a student and they were scribing exactly what you said, you would actually have to tell them, first we have to find a common denominator. So multiply 2 times 4, or 1 over 2 times 4 over 4 to get 4 over 8. You'd actually have to tell them what to write. Excellent. Like Tanya, you're giving exactly what they have to write. You're exactly right. Here's one example that looks a lot like what you are typing in the boxes. To add 2 fractions with different denominators, we first have to find a common denominator. Now I'm going to tell the scribe, multiply 1/2 by 4/4 to get 4/8. Now we can add the 2 fractions because both have a common denominator of 8. Now we can add the numerators, add 5 over 8 plus 4 over 8 to get 9 over 8. So you're really telling exactly what the scribe would have to write. And then after the sage gives that example, then the scribe would become the sage for problem number 2, and they change roles. So I have watched this sage and scribe in classrooms as young as first grade, with first graders being, they call it teacher and student, and one of the students in the pair is the teacher and tells the student what to write, and they just love it. And the language is so incredible that comes out when they do sage and scribe. So you may wonder, like, how could I support my students with Sage and Scribe? It might be that you'll provide sentence frames. So you might provide steps for adding the fractions. So like number one, make a common denominator by multiplying this by this, and give them the language they need, and then add numerators and then the blanks that they would fill in. So that could be enough for even English language learners to become the SAGE if they had these sentence frames for that problem. So this cooperative learning structure called Sage and Scribe, as I said, is from Spencer Kagan. And when you're thinking about how do I get my students interacting and why should I even get them interacting in a math class, there's a ton of research out there that I'd like to share with you at the end of this webinar, because increasing interaction is the second principle for working with English language learners that we introduced at the beginning of the webinar. The research from Spencer Kagan on cooperative learning clearly shows that compared with strategies in which students compete with each other or work individually, cooperative learning has an effect size of 0.78. For those of you that know statistics, that's really high. That's an average of 28 percentile gain for students in a cooperative learning classroom. Like, I want my student in that classroom. Math sections taught with Kagan cooperative learning structures like this Sage and Scribe outscored 8 other sections taught with traditional strategies by 20 to even up to 79%. They were outscoring the other sections taught, the same math concepts just taught with cooperative learning or not. And finally, cooperative learning is one of the best approaches to boosting student achievement. And I highly encourage you to look into Kagan cooperative learning strategies for math. And there are many out there that are specific for math, like that Sage and Scribe. But a caveat, cooperative learning is not group work. And so what I find in a lot of math classes where I have the privilege of working with teachers is that they'll say, in your groups, figure out. So there's a difference between cooperative learning and group work, as you may have noticed with the Sage and Scribe. In group work, any one student could potentially complete the task alone. So it really doesn't need the group. You're just like there's other people hanging around. But in cooperative learning, the students need each other to successfully complete the task. There's a positive interdependence. So as you saw in Sage and Scribe, the SAGE can't write the problem, they can only say it. The scribe, they can't do it alone. They're waiting for the SAGE to tell them what to do. So if you want to call it teacher-student. So you set up a situation that they need each other to complete it. Another difference is that in group work, one or more members of the group can hitchhike. They're along for the ride. They really aren't active participants. But in cooperative learning, there's individual accountability. Each member of that team or group has to participate individually and is accountable for that individual work. In groups, the participation may not be equal on the project. One student may be pinning up the pictures on the poster board while the other one is actually writing all of the content. In cooperative learning, that participation is equal. You're going to switch who's the SAGE and who's the scribe every other turn. In group work, there might be a lot of downtime. Some members of the group are really active. They're the ones using the manipulatives. They're figuring it out. Then everyone else writes the answer. So there's kind of downtime. But in cooperative work, most or all of the members are active simultaneously. It gives you an idea of some differences between that group work and cooperative learning to keep in mind as you set up students interacting together. And even as you view the video, you might think about, is this cooperative or is this group? And how might I switch it up to make that more cooperative? So tonight we really focused on understanding these 3 principles of ELL instruction in math. We didn't get too far into the higher order thinking skills that was embedded throughout, and the video that we didn't watch tonight also pulls out some higher order thinking skills that you can see as a follow-up. We looked at how culture can impact your comprehension in math. We analyzed language use in a math class in a video, and we got to practice one cooperative learning strategy that supports language development in the math class. I thank you all so very, very much for participating tonight in the chat box. It was super active and really great to be with all of you guys tonight. Feel free to email me. I think all of my information is on the front of the handout, and I look forward to working with you again if that's a possibility. And good luck with teaching